Hexadecimal codes, so we have a binary number system on the left, and then we have a hex shorthand on the right. So the hexadecimal number set, we know in binary that our number set is 0 or 1, that's it. And in hex, you can have a 0 through 9 and an A through F. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just as you know today. And then it starts at a 10 is an A, B, C, D, E, F. So that's the hex number system. Should be 15 characters altogether. And the way we represent a hexadecimal, like the A, which is a 10 over on the left, that's a 10. Remember when we looked earlier in this presentation, so we have the power of 2's, right? 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 4. So 2 to the 4, 2 times 2 is 4, times 2 is 8, times 2 is, oh, wait a minute, let's see. So 0, 1, 2, 3, 4. So 0, 1, so it's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So 2 times 2 is 4, times 2 is 8. Plus 2 more is a 10. So that second one from the right is a 2. So the first one, 2 times 2 is 4, times 2 is 8. So it's 0. It's 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. So 2 to the third power. 2 times 2 is 4, times 2 is 8, plus 2 more is 10, and that gives you an A. And then the 15 is the biggest number you can represent in binary with 4 digits. And that's an F in hex. So we don't want to write all these zeros and ones out all the time, and it's easy for humans to make mistakes when we're writing zeros and ones. So we use a hexadecimal shorthand, and that's why hex came about. And there's also another base system. There's actually many, but octal is another. That's 3 characters, and the biggest you can go to that is 8, because you have, I think it's 0 or 1, 2, 4. So 4, 5, 6, 7, 4. Let's see, it's 1, 2, 4. 4, 5, 6, 7, plus the 0 is 8. So that's what it is. It's 0 through 8. So 0 through 7, sorry. So the biggest number you can have in that is 7. So that's how they work. Hopefully that makes sense. It's kind of a poor example, but it gives you an idea. So let's just walk through these. The first one, we probably need to make another chart so you can see, but the way you write it down from right to left when we're looking at this uppermost binary number, 0, 0, 1, 1. So the rightmost number is the 2 to the 0 power. So, and then the second one is 2 to the first power. The third number from the right, which is a 0, is a 2 to the 0, 1, 2 to the 2, and then the last number, the first 0 in that first row under binary number is a 0, 1, 2, 3, right? So it's 2 to the third power. So if any one of those is a 1, you take 2 to that power, that's the number that goes there, and you just add them all up together. That's how it works. So the first one should be 3. So we have 2 to the 0, which 2 to the 0 power is, 2 to the anything power is 1, always 1. 2 to the 0 power is always 1. And then 2 to the first, which is 2. So we have 2 plus 1 is 3. And then the second number is 0, 0, 0, and then the last number, 2 to the third, which 2 times 2 is 4, times 2 is 8. So that's an 8. We talked about the 10 already, and then the F is 8, 9, 10, 11, 12, 13, 14, 15, right? That's where that comes from. So how do computers allocate memory? So we have something called a heap, which is a big old giant stash of memory that we're not using. So how do we allocate it and chop it up and give everybody memory to use, right? We have an HMA, which is a high memory area. We have a reserved memory section, and then we have a conventional memory section. So from 0, we always start from the bottom with RAM and go up. So the lowest address up to the highest address, right? So the conventional memory is 0 to 640, and then from the 640 up to the 1 megabyte is the reserved memory. And then we have the HMA, the high memory area, which is where most of our programs and apps and everything get loaded into.